Ripped River
Oh, so it's
Line.
just a short one, right?
Yeah. Well, I also like the pizza place in Fayetteville, Josie, but if we wanted a pizza, it was a 3-hour wait, so I had scrambled eggs instead.
Well, did you see the secret sandwich society burnt down?
Yeah, yeah, it did. And that was right over by where we were staying, so we actually got to see the burned out husk of it. Okay, so thanks for the correction, Josie. That homework 12 is due on Wednesday. And so, okay, project. Now this is crunch time. If you haven't started on the project yet, today's the last day you can start it and still have a good result. If you procrastinate any further, it's not going to go well. Either because you're going to be scrambling and staying up late, or because you're going to get a point of confusion and stall, or it's just you're not going to have enough time to gather the data you need. And so if you've been procrastinating, this is your last call to get started, because you've got a little under 2 weeks to complete the project. It's due on Friday the 20th. Okay, so today's topic is payback analysis, and it's from chapter 13 of our textbook, and it ties into a couple of subjects that we've addressed before. I think you're going to see a couple of things that you remember back from when we were talking about unrecovered investment balance. The way that this payback analysis is used is when we have equipment we're going to be purchasing for some sort of an initiative, and we want to understand whether it can be profitably operated. So specifically, if you were going to buy, say, just for instance, a steamroller for a certain amount of money, and you knew that that money that you were going to purchase it with has a certain interest rate associated with it, or if you're using your own funds, you know what rate of return you could earn in some other investment. And so that's to say you have a minimum attractive rate of return on the funds that you're going to be putting into this new upfront purchase. And because you are purchasing the equipment, you expect that you're going to have a certain new net revenue that you can generate. So what we're going to try and figure out is how long will it be until the loan can be paid off that you used in order to purchase the equipment. And so that's the kind of question that we're going to be using for payback analysis. And like several other different analyses that we've had, payback analysis is used for initial screening and not as a comparison tool. And so you remember that was kind of the restriction that we used for internal rate of return analysis. When we were calculating the IRR, what we were doing was we were comparing a project's IRR to the minimum, and if it was above the minimum, then we said that that project was potentially acceptable. But what we didn't do was we didn't pick the project that had the highest IRR. And we've talked on several occasions of why that is. And so in a similar way, when you did benefit cost analysis, you can have several different projects and find the B to C for each of them and use that for initial screening. But what you can't do is pick the best project simply on the basis of its B to C. Okay, so those are some earlier examples where we had kind of a similar restriction as we will have with payback analysis. For payback analysis, you can have lots of different alternatives and you can calculate the amount of years it takes to pay off the loan. But just because something gets paid off sooner doesn't necessarily mean that it's the best alternative. But what you do want to avoid is you want to avoid buying equipment where the duration of the payback period is longer than the useful life. And so think about why that might be the case. Think about what would be the problem with having the payback period being longer than the useful life. Well, in a case like that, of course, it would mean that you're paying off the equipment after it's in the scrap heap. And so you don't want to still be making payments, for example, on a car that you don't even own anymore. That is adding insult to injury. So that's what we're going to be looking at here with payback analysis. And so this is the in-class exercise that we looked at. I think this was in-class exercise 18 when we were doing unrecovered investment balance. And in this analysis that we did with that in-class exercise, what we did was we found out up front how much had we put into a project, and then how much interest accumulated during that first year of operation. And so now we had an even higher unrecovered investment balance than the initial amount that we had borrowed or put into the initiative. And then what brought that down was the profits. And so you buy equipment because you're going to be able to generate profits with that, meaning that the revenue coming in for that new equipment is larger than its operating expenses. And so the profits bring down the unrecovered investment balance, but then it goes up a little bit because of that year's interest. And so over and over, through the course of time, what we can do is find out the number of years it takes until the unrecovered investment balance goes back down to zero. And so we had 5 different columns because it's just kind of interesting to look at in a case like this, how much of your payment each year goes towards the principal and how much of your payment each year goes towards the interest. Because when you do a A/P calculation, if you want to know the amount that you have to earn each year in order to cover that initial investment, you would be calculating A, an annual series. You just come up with a lump sum amount. So in this case, what we had was $19,000 something. And that's the same amount each year that goes towards retiring that loan, but a different fraction of that amount is going towards principal and a different fraction of that amount is going towards interest each year. And so up front, when you still owe a lot, more of that amount is going towards covering the interest. But then as the balance of the loan decreases, then a greater fraction of that amount is going towards principal. Okay, so I just wanted to bring this back to your mind because when you look at the homework assignment, this assignment that's posted now and due on Wednesday, so you've only got 2 days to do that assignment, but you're going to need to do the same process as before. So it's kind of review material in a sense. Okay, so the payback period is the number of periods, oftentimes years, where you are covering the initial investment and a rate of return. And by the way, it's not always just about generating new revenue. It may also be that you're buying a new piece of equipment to reduce costs for your company. And so if you can improve the efficiency of a process, or if you can, for example, put in insulation in your house, and now that means that you have to spend less on heating the home, then you could find out a payback period for insulation that you'd put up in your roof, because that would be reducing your electric bill. And so every year you'd have some cost savings, which if you have a reduction in cost, then that's equivalent to an inflow. And so the savings could cover the initial investment. So payback period. Simple payback is when you're assuming what if there's no interest rate. And so that's just simply the amount divided by the number of periods for simple payback. But more frequently, we will use discounted payback where there is some rate of return I that the future amounts are discounted to the present at to find equilibrium. So like I mentioned earlier, payback analysis is used for initial screening, but for comparison, the only way that we can use payback analysis is if 2 pieces of equipment have both the same useful life and the same revenue. And then if that's the case, if each equipment is going to last the same number of years and have the same earnings potential, then you would use it for selection by picking the alternative that can be paid off the quickest. Otherwise, if they have a different useful life or if they have a different amount of revenue over time, then you can't use payback analysis in order to pick the best alternative. And the reason for that is that if you are only picking the alternative that paid off the quickest, that disregards what happens after the payback period is over. And so in today's example, for instance, I've structured the example so that for whatever reason, one of the alternatives starts generating more revenue later in its life. And if you have excluded that after the payback period, then you wouldn't have the full story. And so picking the alternative on the basis of its payback period is faulty if they have a different useful life and different revenue amounts over time. Okay, so let me bring up the in-class exercise. This is the one that I hope you've got printed. In-class exercise 33. And we're going to start by going back to our old friends, the factor tables. And so the situation here is that your company is purchasing equipment that has a useful life of 18 years. Okay? Our MAR is 8%, and we know what the initial cost of the equipment is, $92,000 at the present, and then the annual net revenue, meaning expenses have been taken out of the revenue, so the profit is $11,000 each year. So here in Part A, what I'm saying is use the table lookup factors, which I'll scroll to in just a moment. I have the 8% table on the back side of that form. Use the 8% table to find out how many years to pay it off. And the hint that I give is you need to round up to the larger of the two, because you'll probably be between two rows when you do that. So here in brackets you can see I'm saying for this problem, what is P? What is A? Therefore, what is the ratio P divided by A? And then let me scroll down here to the table. So we're going to go to the P/A table. And, okay, here it is, the present worth table. And so with P equals 95,000 and A equals 11,000, calculate that ratio P divided by A. And so how many years will it take to pay off the equipment? Yes. Wait, hold on. No, it's not 9. The ratio is close to 9. So the ratio 92,000 divided by 11 is 8.364. Yeah, so the ratio is 8.36, and so here on the column, present worth column, let's go down and find where do you find 8.36? Okay, so we're increasing. Here's 8.2 and here's 8.5. So what that means is that the payback period is between 14 and 15 years. So if you have 14 years of interest, 14 years of operation, then you're not quite covering the cost. If you have 15 years, then you're more than covering the cost. And so we should round up to the nearest number of full years, and so it's 15 years. Let me bring up the PDF that I have of that solution. All right. So the ratio is 8.3, and then we get 15 years by just looking for where is the ratio. If we're looking for 8.36, then it's between 14 and 15. So you'd need 15 full years of operation in order to get that. So that's part A. Now use Microsoft Excel to verify this. And so the column titles that I've suggested here is year, amount, PV of amount, and unrecovered investment balance. And so this is something that we've done on several previous occasions. Hopefully it's something that we can figure out again pretty easily. Just starting from a blank workbook, if you have Microsoft Excel available, please fire it up and let's follow along together. Where we start off with the interest rate that's applicable for the problem. It said that it was an 8% interest rate. Okay, so 0.08. And then the column titles that are suggested to calculate this, we're trying to find out how many years, just to illustrate that it's actually 15 years and it's paid off. So it's going to be year, amount, PV of amount, and then cumulative, oh wait, no, unrecovered investment balance. Okay. So we're going to let's look at a 20-year time horizon just to see what happens over the course of 20 years if we have this equipment in operation for 20 years. Okay. And our cash flow situation is that in the first year there's an outlay of $92,000, so negative $92,000. And then in year one, it's $11,000 in revenue, and for every subsequent year of operation, it's also $11,000 in revenue. Okay. So then the PV of amount for the first year, well, we'll do the PV function. So equals PV. Our rate is 8%, so I'm going to anchor the reference up to the interest rate. NPER is just going to be whichever year we're in, and then the amount that we're going to put into the function, got to skip over the payment field because we don't want it to think of that as a recurring, ongoing amount as a payment, but rather it's a single lump sum future value that we're going to be discounting to the present. So we do put in the double comma and the minus sign just to flip what Excel would otherwise do. Oh, and there's that horrible red formatting that I hate so much. I'm going to change that immediately. All right. So now we can drag the function down and find the PV of each one of these individual years. And so we can see, for instance, that 11,000 10 years from now is only worth 5,095 in today's terms. And what we would expect is that that's continuing to get smaller and smaller and smaller because every year in the future it's being discounted another 8%. All right, so unrecovered investment balance. At year 0, all we've done is spent money. And so right now our unrecovered investment balance is $92,000. But then after the first year of operation, what happens is we have our previous year's unrecovered investment balance plus the new revenue that came in. And the revenue that came in we're going to consider in terms of present dollars. And so it is this $92,000 plus the PV of the amount for this year. Okay, now if we continue this trend down, what we're going to see is that it goes from being negative to crossing over into positive territory, right between what we had seen earlier with the factors. When we were looking at the ratios, you know, we had 8.36 and we were trying to find out where did it cross over. One of them was just a little too small, 8.2, and 8.5 is too large. And so somewhere between the 14th and the 15th year is where it crosses over from being an unprofitable enterprise to a profitable enterprise. And so if you have 15 years of operation, then you can make a profit. If this equipment only lasts for 10 years, for example, then you're going to lose money on this. You shouldn't do it if you're only going to be able to operate it for 10 years. So are there any questions so far? Any questions at all?
I'm good.
All right, thank you. So we verified it with Excel as it said in part B. And now there's this function, NPER. We haven't, I don't think, used the NPER function yet, but the way that it works is you put in an interest rate, you put in a payment amount, and you type in a present value, and then it will calculate the number of periods. NPER stands for the number of periods in order to have balance between the payments and the present value. What I don't recall exactly is whether one of those amounts is supposed to be negative. So let's just give it a shot here. Let's try that out together. It'll be pretty clear, I think, if we do it wrong. But okay, so I'm going to do the NPER function here just to verify, because I guess we shouldn't do a spreadsheet unless we do a conclusion here. So conclusion, the project, the equipment is paid off after 15 years of operation. After only 14 years of operation, it is not quite paid off yet. Okay. So, NPER. Rate is 8%. Payment is $11,000 each year. We could either click on one of the cells where it says 11,000, or we can type it in. Either one will work. And then PV, I'm going to guess that I need to put the minus sign in there. Minus 92,000. Okay, and let's see if it calculates the number of periods. Yes, well, it's formatting it as dollars, which is wrong because it's not dollars, it's years. But 14.36 years. All right, so that's pretty convenient. That is part one. So, I mean, I think we can all agree that's pretty simple stuff. And so the fact that the homework's due on Monday, I hope isn't too overwhelming for anybody, because we've already been through the hardest part of the semester. External rate of return, incremental analysis, that's the toughest stuff that we're going to do, and you've already been through it. So it just progressively gets a little bit simpler from here on out. All right, so part two, two pieces of equipment are under consideration, and we want to know the unrecovered investment balance for both of these machines over time. So I don't have a template file for you, but let me just show you the titles that I suggest that you have. We're going to set this up as a spreadsheet. So if you start a new sheet down here at the bottom, so that it's on a different page from the part one, we'll have an interest rate, and I think on this we're still at 8% interest rate. Okay, so 0.08. And we're going to have year, and we'll go down 0 through, the problem says 14 years for machine Y. Okay, and so for unrecovered balance, unrecovered investment balance, we'll have amount, PV of amount, and unrecovered investment balance. That's pretty long there, so I'm going to show you how to wrap text. It's a formatting feature that Excel has, and so click on this cell where it says unrecovered investment balance, and then up here on the ribbon there is this button that says wrap text. And so if you click on that button, what it'll do is it keeps everything just in the width of a single column now. And so we can just make it maybe not quite as wide as it would otherwise need to be. So that was wrap text. All right, and then so all of this is for machine X. And so here's another formatting tip for Excel. Is if we highlight those three cells together and then you click on merge and center, which is up here on the home ribbon, merge and center, what it does is it kind of centers that and it merges the cells so that you could like put a little border around it, and then it makes it clear that these columns are specifically going to be the data where machine X goes. And then we could copy the same thing because we're going to be also analyzing machine Y, and so I'll just change that to Y, and that's pretty convenient. Get these columns the right width. All right, so machine X versus machine Y. So I'm going to pause for a moment. What you need to do is start filling in the data and doing the same thing that I just demonstrated in part one. I'd like you to now apply that process in part 2. So we've got 2 different machines, and since they last for a different useful life, what you need to do is you need to repeat machine X twice. Remember the repeatability assumption? Well, we're going to use repeatability here. Determine the unrecovered investment balance for both machines over time. So we want to find out, in the case of machine X, when does it cross over from profitable to not profitable? Same thing for machine Y. And then here in part B, I'm going to ask you to calculate the present worth of machine X versus the present worth of machine Y. All right, so I'm going to pause, stop talking, give you some time to focus, and start filling in the spreadsheet. Okay, so which one gets paid off sooner? Well, if you were just going to do a single cycle, if you were just going to look at like one cycle of machine X, then it appears like machine X is paid off after the 6th year. But then the issue with machine X is that it only has a useful life of 7 years. And so then that means after the 7th year of operation, you have to buy the machine again. And so that's why you can see here there's a net amount of 9,000 in year 7, because we have the 3,000 in revenue for operating during the 7th year, but then we also have 12,000 in additional costs because we are having to buy the equipment again. So that takes you back from being paid off to not being paid off again. So it's kind of a confusing situation for 2 different reasons. In the case of machine Y, you'll notice that the machine is paid off after 8 years. And so at first glance you may think, well, 8 years is longer than 6, and so maybe it's not the best equipment. But as we're going to see when we do the present values, it is the the most profitable piece of equipment. And the way that we can find the present value of each alternative is one thing we could just add up. No, we couldn't do it that way. We would add up the PV of the amounts. We wouldn't add up the unrecovered investment balance. So we sum all of these and sum all of these. Okay, by the way, was there any questions on anything before this?
I do notice that your 5,730 and 83 cents is the same as your investment balance. Is that a coincidence, or that's well? It looks like it's the same thing on both sides.
I guess that is not a coincidence. No, that is not a coincidence. You're right. That this is telling us the present value of the unrecovered investment balance, and so this this amount right here is after all of the costs are factored in, all of the interest has been taken care of. It's discounting it back to zero, everything up till that point. So yeah, that's very perceptive of you that we didn't even necessarily need to add it all up, because that's what's happening here in these cells. And another way to verify that is with the NPV function. So NPV, if we do, now remember with the NPV function it's a little tricky because we don't do it on the PV of the amounts, we do it on the amounts themselves, and also we exclude anything that's already at time zero. So it's only future amounts that go into the NPV function. But let's just, to refresh our use and understanding of that function, let's use it again here just to triple verify now what is the overall value of each project. So NPV, first it wants to know the interest rate, which is 8%. And then we put amounts that aren't at the present yet. And so these are the amounts, and then we add this outside of the NPV function, the amounts that are already at the present. So that verifies for us that the NPV of the project is 5,730 for machine X and for machine Y. 8% rate. All of these amounts that are in the future, which will be discounted to the present, and add together the amount that's already at the present. And so machine Y is worth 8,000. So the conclusion here is, and we always need to make some sort of a clear recommendation, we should purchase machine Y. It is the most profitable alternative. Even though machine X is initially paid off in only 6 years, the fact that it has to be repurchased again due to its shorter useful life makes it a worse option. All right, so always give some sort of an interpretation to the data. Being able to make a statement like that really drives home the point that you understand what the analysis means, and it turns numbers into decisions. And just being able to put numbers onto a spreadsheet template that I've emailed you, that's good, but what's better is to understand it well enough to interpret the analysis. Okay, so I think that's all for today. That's the conclusion of the in-class exercise. Are there additional questions having to do with the spreadsheet or any function or formula that I did? Okay, if not, let me just refresh your memory that homework 12 is due on Wednesday. And I guess I could bring that up briefly just to show you what that looks like, demystify it a little bit. Here we've got question 1 is one of these price demand type problems. You remember on Friday of last week we were talking, and I think also Wednesday, we were talking about how you can adjust demand by changing the price and finding the break-even points. So that's what question 1 and question 2 has to do with. Question 3 is just kind of a general purpose problem solving. It's not any particular method that you need to apply other than the time value of money, because we do know an interest rate for the future savings. But it's just kind of a general problem solving question. Same thing with question 4. We're going to try and look at how long to pay something off, and so you've got a payback analysis for question 4, question 5, and then in question 6 is where you need to do unrecovered investment balance, and we looked at how you do the setup for that today. All right, and then remember about the project. 15% of your course grade. That's nothing to sneeze at. That's a big chunk of change. So that's it for today. Thanks for joining. Hope you're doing well, and I'll talk to you on Wednesday. Bye-bye.